Okay, good morning class. So today we're looking at equations and inequalities, and this is, let's check, we have completed yesterday exercise 4.9. Okay, so we wrapped up simultaneous equations. Okay. No, we're not done with simultaneous equations. Did we do the sum already? Okay. Now we're looking at problems leading to linear equations. Word problems. Okay, as I'm hearing you guys are really complaining. Alright, so this is examples for exercise. Let me just get the reference quickly. This is exercise 4.10. And so the exercise is on page 92. Thank you. So problems leading to linear equations. So linear equations is basically the highest power on the variable is 1. Okay. So word problems can be represented by equations and then easily solved. We must be able to translate word statements into mathematical notation. The table gives some examples of statements written in mathematical notation. So I cut that out so that we can do it together. Okay. So I know this is basically a short point for some of you. Okay. I'm reading, and this is on page. On page 89. Okay. Alright. So the unknown we're always going to use as x. Okay. So a number increased by 5. So this will simply be x plus 5. You all agree with that? A number decreased by 5. X minus 5. 5 more than a number. X plus 5. 5 plus x is the same thing? Not so? 5 less than a number? 5 less than a number. So it will be? Just hang on. Okay? 5 less than a number. So the number is larger. It's x minus 5. If you're going to say 5 minus x, you will lose the mark. Okay, so why? Because if you say 5 less than 10, what would the answer be? 5. How do you get 5? 10 minus 5. Not so? So if you say a number, in the case of the a number, we let it be x, so it's x minus 5. You understand? So when you are given a word problem, you must construct an equation. Think of a number and substitute that in. Then after, you just replace it with the x. Okay, will make more sense to you. Alright. You understand? Alright. Why are you playing musical chairs today? It's cold, that's it. Okay. 5 times a number. 5x. 5 times a number. 5x or 5 times x. 3 consecutive natural numbers. What does consecutive mean? Numbers follow each other. So if you start 1, 2, then 3, 4, 5. With 3 consecutive numbers, 1, 2, 3. You start with 98, then 99 and 9. 1003, 1004, 1000. Okay, those consecutive numbers. So it's just one more. So if I start with x, the next number is going to be x plus 1, then we add another 1 to that term. Or that expression, you'll get then x plus 2. Okay, any confusion so far? An even number. X plus 2. If x is an even number, it's going to be x plus 2. Okay. Provided that x is even, of course. An odd number. But if you're looking at, before we go into that, It's either you must qualify that x is an even number, or an easier way to always ensure that x is even is by multiplying it by 2. Not so? So if you multiply a number by 2, it will always be an even number. Okay. So it's going to be 2x, or x plus 2. Let's see what the answer in the textbook will be. 2x. Okay. So that's going to be safer to say. Otherwise, you must qualify that x is an even number. Then this is an odd number. An odd number is one more than an even number, not so? Or 2x plus 1 or 2x minus 1 are going to be the same. You guys understand? The next one, the perimeter of it. Just move this up. Here we are told that the perimeter of a rectangle is x meters by y meters. So you got the rectangle. You got x and a y. The perimeter of a rectangle x meters by y meters. Okay, so the perimeter, how do you calculate the perimeter? It's 2 length plus 2 breadth. So what's my length in this case? 1. What's my breadth? X. So it's going to be 2x plus 1. Will you guys understand? Next, the value in rands of x 50-cent pieces and y 2 rand coins. So because they want the value in rands, I must convert the 50 cents to rands. So how many rands are there in a, how many cents are there in a rand? 100. So 50 cents is going to be half. Not so? 0.5. So 0.5x plus y 2 rand coins. So it's going to be 2 times. You guys understand? Or you're going to see the half x plus 2 on. Okay, and then they want your answer to be in rands. Okay. If they want it in cents, however, then it's going to be 50 times x plus 200 y. But that would have been in cents. But that wasn't the question. No? The question was specifically in rands. So that we take out. Next, the numerical value of 2-digit number with a 10-digit x units and x and the units digit y. So it's 10x, yes, since the 10 digits is 10x plus y. Now say for argument's sake the number is 26. Then your x would have been 2, not so? And 2 times 10 is 20 plus 6. You guys understand? What if x was 7 and your y is 3? And that's going to give you 73. Can you see that, people? And so on and so on. Okay? Any confusion so far? No? It's a lot of revision of grade 9. So time taken to run 100 meters at x meters per second. So how do you calculate time? We have the triangle, no? Where the d is always on top. St. Okay. They want the time. How do you calculate time? Distance over speed. So 100 meters at x meters per second. So that will be 100 over meters per second. Or that could have been written as 100 x to the minus times x to the minus 1. Okay, what is that, right? So, okay. I just wrote seconds. Yes, seconds should only be seconds. Why? Calculating time. So it's x meters per second. Sorry, so that is the seconds. Okay. The unit cost of x items in the total cost is y rand. So if you, and again you're going to put your face, but let's go. If there's 100 rand, it costs you 100 rand for 2 items. Then what is the cost per item? 50. How do you get 50? 100 divided by 2. So the same thing you say, ry divided by. Make sense? Right. So let's read here what we are told here. The first decision we need to make is setting up an equation to solve a problem. You should choose what to let the variable stand. Normally we use x, then we say let x be the number, whatever. It is often a good strategy to let the quantity being asked for be represented by x. So if they ask you how old is John, then we make John to be. Okay. Or we normally make the smaller value be x. Okay, you can decide. Why? Because if the smaller value is x, then we will be adding. This the bigger value is x, we will start then subtracting. And adding is easier than subtracting. Not so. Also, by making the smaller value x, we will be multiplying. We made the bigger number x and is a division in the sum. We're going to divide. We go work with fractions and all those things. Okay. So normally we tend to shy away from unnecessary fractions. Okay. But if the question asks for height of a wall, let the height of the wall be x meters. If asked for the price of apples, let the price of apples be x rands. Okay. So let's look at example 1, and example 1 is on page 89. 90. Example 1 on page 90. A cool drink you usually buy is on special offer today. The price has been reduced by 2 rand. This means, per can. This means that you can get 14 cans for the same price that you usually pay 10 rand. Pay for 10. What is the usual price per can? Where do you start? Let the usual price be x, not so. Let the usual price of the can be. Okay, you guys understand? So if the usual price is x, so the new price or the discounted price, the special price, would then be equal to what? 2 rand less. So it's going to become x minus 2. Not so? So how do you work out the cost normally? We'd say, for the total cost, we say the number of cans multiplied by the price per can. Not so? So if you look at this here, if you wanted to buy 10 cans at normal price, the normal price will be equal to x. So in other words, it's going to be 10 times x. It will be your total cost, usually. Not so? Now we are told that the price is reduced by 2 rand, but how many cans do they get now? 14. So it's going to be 14 times x minus 2. So again, just take one step back. 10 times x will give you the total cost for 10 cans at normal price. Not so. Whereas this 14 into x minus 2 is 2 rand less for 14 cans. Not so. But what did they tell us importantly? That the prices are the same. Not so. So here it says, this means to say you can get 14 cans for the same price. So if it's the same, then they are equal. There we go. And then what did we do? We set up an equation. You can understand? Right. So 10 times x is 10x is equal to 14x minus 28. X is one side, numbers the other side, so negative 4x is equal to negative 28. X is then equal to 6. So what? Huh? 7. No, I say 6. No, I did wrong. Huh? X equal to 7. So what does that mean? Does it mean to say that the usual price of a can is 7. And what is the discounted price? 5. Does 7 minus 2? Minus 5. Take down what you need. You must get the word problem, no? You won't get it in every exam, but you should get it in. In this exam. Oh, I don't remember. Yes? Sorry? What? What's he say? You know you're sitting in a normal maths class. So I don't have time to teach you stuff that is not important. So what do you think? You just want to talk to me a little, no? Okay. People, she asked if there's going to come, if you need us for normal maths, or for maths lit, we don't have time to do any of this stuff. There's a lot of things I want to tell you before you write to find grade 12. A lot of things. A lot. Okay. So, there's no time. Yes?
Is the net XP, are you going to do one mark straight?
No. In grade, that was grade 8 and 9, grade 10 now, my girl. Right. We are told that the 10th digit, the 10th digit of it. Listen, this is also the reason why you do English. No? Is to read your maths questions. Otherwise, you don't need to read. Not so? Yes. Okay. Nice. We are told that the 10th digit of a 2-digit number is 2 more than the units digit. Okay? Let's read it again. With understanding maybe this time. Right, so the 10th digit. So basically, remember that when we looked at the example, we looked at 10x and y. Not so? So it's to somewhat this understanding. Okay? The 10th digit of a 2-digit number, which is the x, is 2 more than the units digit. Okay, so the 10-digit number, or 2-digit number is 2 more than